Okay, class, so chapter 5 is about the research design. You can see my voice clearly, right?
Yes.
Okay, chapter 5 is about the research design, okay, which is on chapter, if you write the thesis, that would be on chapter 3, okay, research, the methodology, chapter methodology. So this is the content of the chapter 5, in which chapter 5.1 is the methodology, experimental setup, and how you design the experiment, sampling and case study, measurement or the data collection, and lastly is the evaluation. Okay, let's look at the methodology first. So research methodology is the specific procedure or the technique used to identify or select or process and analyze the information of the topic. That is true because in chapter 3, everything is all about on your own. Okay, everything that you write in the chapter 3, okay, I mean your thesis in chapter 3, everything is about the procedure, about first of all it could be the flow chart first. Okay, first of all it should be the flow chart. Okay, how do you plan to solve, okay, or achieve your objective? So you must start with the flow chart. Okay, so the reader or the panel know, okay, what is your flow and how are you going to achieve your objective based on the flow chart. Okay, based on the flow chart. So, okay, so if the flow chart is good enough, actually they can tell the panel or the reader the everything about your project if the flow chart is good enough. So actually, the flow chart itself can tell the reader what is the how are you going to achieve your objective. Okay, so it is very important, especially the flow chart. So it would be good if you can show that your flow chart, which part of your flow chart can achieve. I mean not. Okay, let me explain like this. Okay, you can highlight the flow chart. For example, which part is your contribution in the flow chart? Do you get what I mean here, class? Let me show you some example. Okay, if you look at this flow chart, okay, this is the flow chart. So with different color, so it can identify this part is the data collection. This blue color is another data collection. Then combine, okay, combine. Then after your data collection, okay, what after that you process the data and you analyze the data. Okay, what is after you collect the data, how you use the data to do the analysis. Okay, for example, you want to characterize the rate attenuation and the prediction, so you will analyze in terms of seasonal variation, diurnal variation, stratiform rate, and convective rate, and also you so this will be the measured time series. So this one, you see the dotted line. This dotted line actually is referred to the research contribution. Okay, and another part is okay. After that, this is another. The blue color is another set of the equipment, and then you collect the data. After collect data, you process the collected tips. Okay, this one is highlighted. Okay, is you circle dotted circle line. This dotted circle line means that it's a contribution also. Okay, you see that research contribution, and then you get the time series, and then you analyze the data in terms of the stratiform, convective, SCST, and SST. You do the prediction. Okay, after you do a prediction, you validate. Okay, you validate the cumulative distribution function of the rate attenuation, pet duration, and phase slope. Okay, this one also their contribution. So in order to let the panel, okay, know about your project and where is your contribution, it is very recommended, okay, to highlight like this. Okay, you circle it so that your panel know that where is your research contribution. Okay, this is the flow chart. So from the flow chart, you know that, okay, the panel know that you have two set of data. After the two set of data, you analyze the data. Okay, this where is your contribution? You analyze the data. So this this thing is a contribution, and for another set of data, this part is a contribution, and then lastly is this part of the. So totally, for PhD, of course, for PhD is the 3 new contribution, but for master it could be just 1 or 2 would be just enough lah. So it depends on your supervisor. Okay, it depends on your supervisor. All right, so you understand now. Okay, if you do in term of the flow chart, you must highlight so that your panel know about your contribution. Okay, now let's continue. Specific procedure or technique used to identify, select, process, and analyze information about topic. And then in a research paper, methodology section allowed the reader to critically evaluate the study overall validity and reliability. Means that in a good research paper, a good journal, for example, a Q1 paper you read, then you're able to reproduce the same result because the data itself or the result itself or the explanation itself is very good until you're able to duplicate the same result. Okay, because all the thing or detail are very clear, parameter are very clear, so you can duplicate, so you can evaluate the study of that paper. Okay, the validity and reliability, you can try to do the same thing again, whether you can get it, provided you use the same parameter as the um, journal paper. Okay, so what should include? The methodology chapter explain what you did and how you did it. Okay, allow reader to evaluate the reliability and validity of the research. So this means that in your chapter 3 you must explain what you did. Okay, everything in this chapter is your own project. It's really about your own project. It does not seem like the literature review that you copy, not to say copy, you summarize the idea or summarize the literature from the previous works. Okay, but in chapter 3 everything is about your work. Okay, everything is about your work, so you explain what you did and how you did it. Okay, so it should include how you collect your data. Okay, you explain how you collect data, how you analyze your data. Okay, after analyze, what is the indication? Okay, what you get from the data? That is very important. Not only you produce the result, but what is the meaning of that graph? Okay, indicate of what? Okay, so you analyze your data. What are the tools and material you use in the research? For example, what is the equipment? Okay, how do you calibrate if the calibration is needed? Okay, you calibrate the data, calibrate the tools or equipment. Okay, and what is the material? Okay, if you do for the material, what are the material? What is the capacity, or how to say? Let's say if you combination of 2 material you mix together, so you know what is the how many gram of this material and how many gram of that material, then mix with the water. If let's say like this lah, then you know the quantity or the weight of the material. Okay, and the parameter, what is the input parameter? Okay, all these are important. Then why you choose this method? For example, you have few method to do this kind of things, but you choose only one. Okay, you don't say that, oh, because this method is easy. No, you don't say like this. You don't say, oh, the method is easy for implementation, then you choose. No, you must review first. So that's why in the literature review, you must how to say, you must review those every technique. Then from a technique, you summarize, okay, what is the drawback, what is the benefit, or what is the remarks of this method. Okay, then at the end of this summary, you say, okay, in this research, I will choose this method because of what that is the reason. So similarly, in the chapter 3, you also need to explain why you choose this method. Because normally the panel will ask you, why you choose this method? Why you not choose that method? So you should prepare some this kind of question. All right. And then quick, this is the example for the abstract. Okay. So this one, several studies have reported pre-programming of the fibroblasts into induce cardiomyocyte. Okay, I can't see clearly. However, the reprogramming into the proliferative induce the cardiac progenitor cell remain to be accomplished. So this one actually to tell you the topic. Okay, summarize what already known and what have accomplished before. So actually in your assignment, okay, we also give you, okay, we ask you to highlight what is the background, okay, which sentence is about the background, which sentence is about the method, which sentence is about the result. Okay, so abstract must include few things lah. You first of all you must some few sentence of background, okay, then few sentence of the objective or the method. After objective, what you want to achieve in this. After that, you have the method. Okay, after the method, the method means that the methodology, the way you propose you propose your method to solve the problem, and then what is the result? Okay, what is the result? And then what is the importance of this research? So in the abstract, you have few things. So I believe that in the assignment you already you have did it, that you have highlight these few kind of things lah. Okay. Qualitative and quantitative. What is the difference? Okay, quantitative research is expressed the numbers and graph. So it is used to test and confirm theory and assumption. This type of a research can be used to establish generalizable facts about the topic. So quantitative, you were talking about the numbers and graph. While qualitative, expressed in word, it is used to understand the concept, thought, and experience. This type of research enable you to gather in-depth insight on topic that are not well understood. Okay, so you have two types. Okay, one is you express things in graph. Okay, you can see the graph, the numbers. Okay, you they use the result to confirm the theory. And another one, qualitative, means they explain it in concept. Okay, explain in concept. So in explain in text lah, normally. So this is the method of qualitative and quantitative. For qualitative, okay, via interview, via case study, focus group, okay, action research or survey, media analysis, okay, biography, concept mapping, thermal analysis, record keeping, okay, and derivation. While quantitative is about the experiment, survey, observation, simulation, statistical analysis, optimization, meta-analysis, audit, content analysis. I think this one, if you are FK for engineering, mostly are quantitative. Okay, quantitative. For qualitative, they are like interview more to the social science. Okay, they're based on the people uh, the interview result. Okay, they interview some people, so what are their result, they survey, do the survey paper. So those are qualitative. And for our engineering subject or research, more to quantitative, because we do the experiment. Okay, we observe the result, we run the simulation, and we do the analysis. Okay, we analyze in statistically. So how do you validate your result? So any selected method ideally must be validated in order to ensure its the reliability. For example, how do you validate your mathematical model developed for a system? How do you? Okay, how do you validate? Okay, so you propose a model. You must able to validate the model either by compare to other mathematical model, okay, similar trend or not. Okay, then you explain. Okay, then how do you validate the simulation? Also the same, you can compare with the previous research result. Okay, previous result in the journals. Okay, how do you validate experimental procedure? So you must follow the procedure lah. So let's say you follow the manual, or you follow the guideline. Okay, or you follow the procedure which is published in the journal, so you also can cite it. Okay, how do you validate qualitative methods? For example, interview. Okay, you interview, of course you interview, you are not cannot just interview 5 to 10 people. You must interview a lot of people, which is from different category. Okay, you interview perhaps teenagers, okay, for more less than 20 years old, more than 20 to 30 years old, 30 to 40 years old. It depends on what you want. For example, a health problem. Of course, that those less than 20 years old should be no problem lah. Then mostly those who have a health problem should be more than 40 or 50 years old. So if you do this kind of interview, okay, the survey form or question A, you must able to categorize. Okay, you must able to not only just few person, you must do a lot of paper. Okay, and for example, for the health problem, for example, you want to do the health problem and then you do the question A. Okay, you must know the probability for the range of these people must be equivalent. Cannot say, oh, 40 to 50% I only survey for 10%, and 20 to 30 years old you survey for 20%. So cannot. You must same. Okay, otherwise later on the result will be biased. Okay, okay, because the health problem is mostly is more than 50 years old has some health problem. So if you uh, survey those people just less than just 20 to 30 years old, a lot of people from this category, so of course they don't have much problem on the health issue. So you must able to categorize and identify, okay, what is the problem and which category. Okay, 5.2 is about is there any question to ask before I go to 5.2?
Doctor,
Hmm.
Doctor, how about if our project is building a system like a prototype?
Okay, if you build a
Is
prototype,
it?
you must
Yeah.
do know the functionality, whether it's able to function or not, and it tests the performance of the system lah.
Okay.
What kind of system you want to test?
Huh? My system.
Ah,
Um, a radiation pattern system,
radiation pattern,
measurement system,
measurement.
measurement system.
So first of all, you
Mm.
must know that your measurement procedure should be correct lah. Okay, the measurement
Uh-huh.
procedure should be correct. Okay, and
Uh-huh.
you get the result. Okay, you get the result, and then you can compare with the previous result from the literature whether you get a similar
Uh-huh.
pattern or not. If the pattern is
Okay.
totally different, okay, the radiation pattern, for example, is
Uh-huh.
totally different, okay, it's very weird shape, then you must
Mhm.
redo your measurement.
Okay.
Mm. Okay,
Okay, thank you.
welcome. Any other question? Do you have any other question?
No, thank you.
No, okay. So if no, I shall continue with next one. That is the experimental
Mm.
setup and design of experimental experiment, DOE. Okay, design of experiment, we so-called the DOE. Design of experiment is a systematic method, okay, to determine the relationship between the factor affecting the process and the output of that process. Okay, you should know what is the factor that affecting the process. Okay, factor and the output. Okay, whether the output that you obtain is the one you expected to get this output or not. Okay, so in other words, is used to find the cause and effect relationship. Okay, this information is needed to manage process input in order to optimize the output. So you must know what caused the output like it looks like this. For example, your friend said, Nazura, he said, oh, radiation pattern. Okay, for example, the man loop. Okay, you have the antenna. You run the simulation. You have the man loop. Okay, let's say the man loop does not exactly like a man loop. It's more like a there is a It's very weird shape, for example. Okay, weird shape. So you have to know why that what is the factor, or what is the cause that cause to that very weird radiation pattern, or what is the weird of that the man look. So you have to find out. Okay, what is it, whether it's a design problem, or because there is a blockage of during the transmission, or what. Okay, so you have to know about this one. You need to know the factor. You cannot say, oh, okay, I run a simulation, I follow the procedure, I run a simulation, and that is the result I obtain, then you present the result. You are not a researcher. I would say you are not a researcher, because a good researcher, you have to, first of all, you have to make sure your procedure is correct. Okay, you, after that you get a result. After you get a result, you cannot say, oh, this is the result I obtained, that's all. Cannot. You have to compare whether the result that you obtain is the correct one, is the expected one. How do you know it's correct or not? You can compare. Okay, you do a lot of literature review, right? You do a lot of literature review. So of course, they, I mean, other researchers should also present their, for example, their radiation pattern. So is it the similar trend? The shapes are the same or not the same? Okay, if you are correct, means that the trend should be not deviate too much from the trends of your result lah. Okay, if so much, if the your the graph that you obtain is deviate too much from the previous, then you have to redo again. Okay, you identify why you obtain this kind of graph. You cannot accept that this is my graph, then you say, this is, okay, my graph, this is correct, this is my result. Then you will hard to justify. Okay, if you want to publish a paper, okay, it's very hard to justify. Why? Because somehow you get the result which is different from others. You must able to explain. Okay, the graph look like this because of what. Okay, you need to know the factor. Okay, if like for example, you have to explain. If you don't explain, this is not a good research paper, because you had to publish in a high impact journal, because you didn't explain. Okay, you didn't explain the result, you didn't analyze the result, you just show the result, but who knows this your result is correct or not, right? If you publish, if you send a paper for review, I'm sure that the panel will ask you why the graph look like this, and what is the reason behind. Okay, so that's why you need to explain. Okay, experimental design and process. So first of all, okay, if you first of all, you need to define the problems. What is the problem you want to solve? Okay, then from there you can determine the objective. Okay, you have the problem. Okay, you have the problem. Okay, you know what you want to solve. Okay, so you can determine the objective. Okay, at least three objectives lah, for sure is a minimum is three lah. We won't say four or five, but normally we use three objective only. Okay, these three objectives will help you to achieve the objective. Okay, these three objectives will help you to accomplish your project. Okay, step by step lah. Okay, then number three, determine the response and factor. Okay, if from how to achieve your objective. Okay, the objective must be measurable. Measurable means that can measure, can show in a result. Okay, can you the something that can measure, can present the result. Okay, then you design your experiment. How to design means that you either how to achieve, either you want to do the correction, or you want to do the measurement. Okay, the data collection via measurement, or you want to do the question A survey, or how. Okay, so you design your experiment. Okay, this is based on the objective lah. And then number five is conduct experiment. Okay, you already decide to um, conduct a measurement. Okay, from the measurement you can collect the data. After collect data, you can analyze the data. Analyze means that you from the data itself, you can plot graph, okay, plot the table or plot whatever lah. Then from there, not only the data you obtain, but you need to interpret the result. Why you obtain such kind of result like this? Okay, and the verified means uh, you verify like validate your data. Okay, validate your result with the previous research from the research paper. Okay, and then additional experiments are as required. So if let's say you feel like is unable to validate, so you have to either redo the same things or you find another alternative. Okay, this one is experimental design guidelines. Okay, so this DOE must be able to address the following questions, such as the factor, the levels, okay, the factor to be tested, the level of those factor, and the structure and the layout of the experimental run and condition. So a well-designed experiment is as simple as possible. Okay, make it as simple as possible. Obtain the required information as cost-effective and reproducible manner. Okay, not too expensive, but the result is able to reproduce. Okay, this is the example of an experimental component for these three factor, level, and response. So, for example, the factor, okay, the factor should be the uh, variable or the input, such as the iron, sugar, flour, or the eggs. So, this one is you want to make a cake. Okay, you want to make a cake. The output is a cake. Okay, the response means the cake lah. Okay, what you need, what is the input or what is the ingredient. Okay, normally we said if you want to make a cake, what is the ingredient? The ingredient that you need is the sugar, the flour, and the eggs, but you need the oven to bake. This is your equipment lah. Okay, for example, this is your material. Okay, your material, but this is the equipment. Okay, and the level. Okay, for example, if you want to bake the cake, you must set to a certain temperature, 160 degree or 180 degree. Okay, you cannot set to just 100 degree, and the cake, you will never get a cake like this. Okay, and you need the measurement cup. Okay, sugar, how many uh, cup? Okay, or what is the weight, or how many egg you need to, big size or small size of egg. Normally we just count one or normal medium size or large size of the egg, two or three, okay, eggs. So to produce the cake like this. Okay, so this is the factor, level, and the output component. So similarly, if you want to run the to do the measurement, you need to know what is your equipment. Okay, what is the material used? Okay, what is the software? Okay, if you use the material, different material, you need to measure the material. How many liter of water? How many liter of this? How many liter of that? Okay, what is the equipment? Whether the equipment need a calibration or not. Okay, to produce this the result that you want. Okay, so you have to somehow, for the measurement, you need to repeat few times. Okay, whether you get back the same things or not, the same procedure, same material, same quantity, you repeat to 2 or 3 times to make sure that you every time get the same things. Okay, and you can get the mean value of these 2 or 3 from these 2 or 3 experiment. Okay, potential designing difficulties. What is the difficulty? When designing an experiment, for potential trap that can create the experimental difficulty. Okay, first of all is unexplained variation. Okay, this means that, okay, other sources of error that is either within an experimental run or between experimental run and associated with level setting changing. Properly designed experiments and can identify and quantify the source of error. So this means that you unable to explain the variation, why you get the error like this. Okay, and uncontrollable factor, the noise factor, Okay, you want to get a signal, but the signal plus with noise. But this noise is you unable to get rid of it. So these factors such as multiple machines, multiple shift, raw material, humidity can be built into the experimental so that their variation does not get lumped into the unexpected or experimental error. So some factor is hard to avoid. And correlation, two factors that vary together may be highly correlated without one causing the other. They may both be caused by the tag factor. So that's why you need to validate uh, your procedure and your result. Let's say you will get a different you get the unexpected result, so you have to redo the experiment to make sure that uh, the procedure is correct. Okay, if let's say you still get the same things and then you still don't know why, perhaps you have few variation parameter, so you have to set one is fixed like this, and only each time only one parameter is variable to identify which one caused the problem. Okay, and combine effect or correlation factor demand carefully through the prior to the conducting experiment. Combine effect lah. So that's why I said if you want to identify or troubleshoot the problem, you have to do it one by one. Okay, do it one by one. Let's say, for example, here, consider an experiment to grow plants with two inputs, water and fertilizer. Increased amount of water are found to increase the growth, but there is a point where additional water lead to the root rot and has a detrimental impacts. So it's true that the plants needs water, okay, and fertilizer, but you cannot put too much. For example, or 2 weeks, 1 to 2 spoon for every 2 weeks. You cannot put. Oh, I say, I'm lazy to put the fertilizer every 2 weeks. Maybe I can put 5 spoon or 6 spoon in one time, so that it can last for 1 month like this. No, it's too acidic. So the plant will be spoiled. Okay, it's the same things because it's too acidic. Okay, so any question for 5.2 for the DOE class? Hmm? Nazura, any question?
I know.
Okay, what about others? What about others?
No, madam.
No, doctor.
Okay.
Doctor,
Yep.
uh, let's say potential design difficulties that should be always described by formula or just a narrative explanation.
Pardon?
Regarding potential difficulties when we have difficulties during experiment,
Uh-huh.
let's say variable factors or ambient or whatever they have impact to our experimental that should be explained by a formula or only by narrative because uncontrollable.
Okay.
How do we
You can
describe
just
in our
explain it.
methodology?
You can explain it. Narrative explain it. Mm.
So narrative explanation only.
Yeah, you can explain it. It also
Okay.
depends on your research lah. Let's say if the problem is from the formula, okay, because you run a simulation using the formula or the models, but you get the unexpected
Yes.
result. Okay, if you do the experiment, you can say I repeat the experiment, but you say you run a simulation, okay, so you need to know which input parameter, okay, is affect to the simulation result, so you can test each one. Okay, and then whether
Okay.
model itself, which, because somehow the model is wrong, I mean it's quite long models, so you need to know which part of the model contribute to that result. So perhaps you can test one by one input that
Okay.
contribute to a very weird result. Okay.
Okay. Thank you, Doctor.
Welcome. Okay, so if you have no question, then I proceed to the sampling and case study. Is it okay? Okay,
Okay, Doctor.
all right. So next is a sampling and case study. What is sampling? Okay, to draw a conclusion about the population, it's possible to collect data from every person in a group. So sampling is a way out. Sample is the group of individuals who will actually participate in the research. Okay, there are two types of sampling method. One is a probability sampling, which is involve the random selection, allow you to make a strong statistical inference about the whole groups. Another one is a non-probability sampling that involve non-random selection based on the convenient or other criteria, allowing you to easily collect data. So this one is about the sampling. Okay, you want to take the sample. Okay, either you make the probability sampling, random selection, or you it's a non-random selection, means that you actually is set by yourself. So there are a few method of the probability sampling method. The first one is the simple random sample. Okay, this simple random sample is based on chance selection, based on chance. The second one is the systematic sample. Okay, this is the selection based on regular intervals. Okay, after few intervals, you select one samples. Okay, and stratify samples. This means dividing the population into subpopulation that may differ from important ways. Okay, so you divide it. Okay, divide the population into subpopulation. Okay, and cluster sample, dividing the population into subgroups. Each group have a similar characteristic to the whole sample. Mostly this one, if you take a sample or question A from the group of people, mostly are from the social science lah. Social science, they will do a lot of question A. They want to do a question A from a different group. For example, for the about the working experience or employment, we have to, or they have to collect the data from different people, which they have the different job. Okay, different job or different position. So mostly they use for the social science peoples. Okay, social science study. Non-probability sampling method, for the convenient sample, is a selection of individuals who is most accessible to the researcher. Means that easily I can approach to who, so I give it to her like this, or him or her. So it's a convenient sample. They didn't pick up, oh okay, what is my target? No, they just convenient. Purposive sample this means that the researchers select a sample that is the most useful to the purpose of the research. Then they choose the most related, okay, the targeted people. Snowball sample, rescue participant via other participant. Okay, maybe you say, oh, I want to do some question A. Can you just help me to pass to your friend? Okay, you just anyone. You didn't target the group. Who should you target? Okay, for example, you want to target a group of the uh, working in the company. Okay, working in the company, but they send to the people that working in the uh, outdoor. For example, the worker, normal worker, like a lorry driver. They didn't target, they just send out only. So they just snowball sample via they rescue participant via other participant. Quota samples means that specific quota is allocated for people with different characteristic. Okay, they say, okay, I want to get a 10 sample or 20 sample from the lecturer group, 10 sample from student groups, 10 sample from the company group, 10 sample from the farmers, okay, 10 sample from lorry driver, something like this. So they have the quota, so that they divide the group equally. Okay, they get the sample equally from this group. Case study. A case study is a research approach that is used to generate an in-depth, multi-phase understanding of a complex issue in its real-life context. Case study also allow you to explore the key characteristic, meanings, and implication of the case. It is used extensively in a wide variety of the discipline, particularly in social science. So this one, case study, also suitable for the social science. Okay, suitable for the social science. Okay, case study. So this is the example of the case study that they want to ask about. This is the research question. What are the ecology effect the wolf reintroduction? How do the populist politicians use the narrative about history to gain support? Okay, this is the research question. And then how can teacher implement active learning strategy in mixed level classroom? What are the main advantage and disadvantage of wind farm for rural communities? So this is a research question. Okay, you want to ask. Okay, you want to know. Okay, so you form this research question at the early research. Okay, and then a case study is a case study of the wolf introduction in Yellowstone National Park. So you, okay, for example, this one, right? Wolf wolf the introduction. So they study at where? Yellowstone National Park. So they start the study only at the Yellowstone National Park. Okay, and this one, case study of Hungarian Prime Minister Viktor Orban and US President Donald Trump. Okay, so they only study this person specific to this Hungarian the Prime Minister and US President. So they only study for certain person. Okay, for you have this research question, but the case study only refer to particular person only or particular case only. For this one, case study of the local school that promote active learning. Okay, so the research question is how can teacher implement active learning strategy in a mixed level classroom? So they carry out the case study of the local school that promote the active learning. Then what about this one? What are the main advantage and disadvantage of wind farm for the rural community? So case study of 3 rural wind farm developed project in different part of the country. So the case study is mostly related to the research question. Research question is in which you set early of the research. Case study is, you can say, the review. Okay, the review of previous research, or you can do the case study itself that's specific to the person. Okay, specific to the national park, specific to this Hungarian prime minister, or specific to this president. Okay, specific. But I don't think that engineering subject or research normally you use the case study. Okay. 5.4, I think I have 2 more left, 5.4 and 5.5. Okay, so this is for this chapter I just left about 10 slides. So maybe I will reserve this 2 subtopic to next class. Is it okay, class?
Okay, doctor.
Okay, doctor.
So today we will have
Okay, doctor.
a 1 hour class, and then another class will have, I think should be also another 1 hour lah. So today I will just stop here on the. Is there any question you want to ask, class? Which part you are not understand, or you can ask about your project also. Okay, class. Before that, soon I will distribute to you a project which is about the your proposal. So every one of you, you can do the proposal based on your project. Okay, a proper proposal in the form of the manuscript, in the form of manuscript and IEEE manuscript. But of course, the proposal that you prepare for the proposal defense is not the same lah. But I want you to prepare your project, okay, based on the title given by your supervisor or you propose it. So maybe this week or early next week, I will give it to you so you can do based on your project lah. Okay. All right. Okay. Any other question, class?
Doctor add the chat box.
At the chat box. Okay. Muhammad Sazlan. So how many minimum sample is accepted? Yeah, minimum sample. It depends on whether the sample is based on what. The sample is from the question A. If question A you did a lot because you cannot just get the percentage based on few people. You need a lot. I think maybe more than 100 for question A. For the sample itself, I mean for the measurement, for the measurement, it depends also because let's say you want to make sure the result that you obtain every time is the same or not the same, right? So you can take few samples and you average the result. But anyway, you have to ask your own supervisor whether this is the correct way lah, because the different research you have a different method. Cannot say one method is suitable for all. All right. Okay, class. Any other question? Any other question?
No,
Eh,
doctor.
Okay, if no,
Not from me.
okay, if no, then I shall stop here. Then you get ready with your QR scanner and we scan for attendance.